we learned how to model the process of a control system. In general, the process can be modeled by a mechanical system. Then we learned how to model the controller. The controller can be modeled by an electrical system. In this lecture, we will learn how to model the actuator and the sensor. It is no wonder that the actuator and the sensor are electromechanical systems. We can also call them mechatronic systems. You can think of them as the connection between electrical system and the mechanical system. They can also be regarded as energy conversion devices. Actuator could be electric motors. Generators and electric sensors could be served as sensors. To understand the operation of most electromechanical actuator and sensors, it is important to understand that electric current and magnetic fields interact in two ways. The first way is law of motors. If we let a current flow through the inductor, then if we arrange this inductor with current in a magnetic field, then there will be a force. The direction of the force is determined by the right-hand rule. The force is perpendicular to the plane determined by the magnetic field and the current. If you use your right hand, you extend your thumb. That is the direction of the current. Then all other fingers point to the direction of the magnetic field. That will be from the N pole to the S pole. Then the force is pointing up. The magnitude of the force is B times L times I. B is magnetic flux density. Its unit is Tesla. L is the length of wear through the field. I is current. Its unit ampere. Now let's look at this figure. We have an inductor with the current flow through. we have a magnetic field. Then let me ask you a question. What will be the direction of the force applied to the inductor? I will give you a few minutes to think about it. The force is to the right. To determine the force, the direction of the force, you can use the right-hand rule. The current is flow in this direction. If you use your right hand, it will be direction of the thumb. Then all the other fingers pointing up. So the plane determined by the current and magnetic field will be this plane. Then force is perpendicular to this plane. It will be, the direction will be to the right. Then the magnitude of the force will be B times L times the current. Now let's see an example. Let's see how to model the loudspeaker. Let's cut through the loudspeaker in the middle. Then we have the side view. In the middle, it is a permanent magnet. The permanent magnet establishes a magnetic field between the poles of the magnet. It's from the N to S. Then if the current is fed through the coil, the coils are wound on the bobbin. Now let's see what happens if there is a current and magnetic field. They will be forced by the law of motor. So let's assume the current is into the paper. The current is into the paper, is on the top is into the paper, on the bottom is out of paper. Let's say the current is in this way, go in on the top, then out at the bottom. Then if you apply the law of motor, what will be the direction of the force? I will give you 1 minute to think about it. Again, in this case, the force will be to the right. You can use the right hand rule. Thumb is the direction of the current. On the top, it's into the paper, and all the other fingers point to the direction of the magnetic field. Will be to the top. Then the force will be to the right. The same for the bottom, but in this case, the current is out of the paper. Then the magnetic field is pointing downward. Then the force is still to the right. This force will cause the coil to move to the right. Then it will cause the motion of the cone. The cone is connected to the bobbin. At two ends, it has low force suspension. Then the cone pushes the air, creating sound waves. Now let's model the loudspeaker. We take the current at the input, I, the current fed into the coil at the input. Then the motion of the cone will be the output. Say this is the X. Then let's assume the effects of the air can be modeled as if the cone has equivalent mass of m, the viscous friction coefficient as B. First step, let's draw the free body diagram. So this is a cone, the mass is m. Then we know by the law of motor, there will be a force F. Then the friction will be in this direction. The friction constant coefficient is B. Magnitude is B times first derivative of X. Let's use this direction as a reference direction, and also this direction, the acceleration direction. Then let's first determine how large this force. Based on the law of motor, we know it is F is B L I, and here I is the input. Then we assume the magnetic field B is 0.5 Tesla. The bobbin has 20 turns at a 2 centimeter diameter. Then first step, we need to determine the circumference. Then we times 20, we get this, the length of the wire. Then the wire length will be L is equal to 20, 20 turns times circumference will be 2 centimeter times pi. It will be 1.26 meters. Then we can apply the law of motor. F is B L I. It is 0.63 I Newton. Then we apply the Newton's law. Newton's law tells us the sum of the force is equal to m times acceleration. The sum of the force is m minus b x first derivative. This is the sum of the force. Then m is mass. Then x second derivative will be the acceleration. Then we can apply Laplace transform to this equation. We have m s squared xs 0.63 is. This is the input, is the output. B s xs. Then we can move bs xs to the left. Then we obtain the transfer function. This is the transfer function for the loudspeaker. We use the current as input and the motion of the bobbin and output.